Alright, so the last thing we're going to talk about is symmetry. And there's two types of symmetry that we will refer to. Okay? There's even and there's odd. Okay? There's even and there's odd. Even functions are symmetrical to the y-axis. Meaning if you fold your graph over the y-axis, it would match up perfectly. The one we just did was an even function. Okay? The graph we just did, this is a new video here, this would be an even function because if I fold this graph right over top of that y-axis, it would match up perfectly. That's an even function. It's symmetrical to the y-axis. And then you have an odd function, which we say is symmetrical with respect to the origin. It's symmetrical with respect to the origin, which means if I rotate the graph around the origin, it would look exactly the same. So here's the graph of y equals x cubed, right? One of them that we know, y equals x cubed, right? It's a rough sketch of y equals x cubed. Just take a look at the sketch of the graph right now. It passes through the origin, it's headed up into the first and down into the third quadrant, right? If I spin it 180 degrees, does it look any different? No. Y equals x cubed is an odd function because it is symmetrical to the origin. If you spin it 180 degrees, it looks the same no matter what. Okay? So that's one way you can tell something is an odd function. Okay? Y equals x squared, what type of function is that? Why?
Because it's parabola, so you just flip it over the origin, same thing.
Isn't y equals x squared symmetrical to the y-axis? So y equals x squared is an example of an even function. Y equals x cubed is an example of an odd function. Even and odd powers a little bit there, right?
Oh, that's interesting.
Okay, so maybe it's an easy way to help you remember a little bit there. Now, just because something has an x squared in it doesn't make it an even function. But the parent function is y equals x squared and y equals x cubed. X squared is even, x cubed is odd. Okay? Algebraically, how can you show something is an even or an odd function? Okay? This is what you will do to prove something is even. If f of x is equal to f of negative x, you have an even function. If f of x is equal to the opposite of f of x, then you have an odd function. And just kind of in general, let me explain why this makes sense. Let's think of a parabola, right? If I plug in a 3 for x on y equals x squared, so if I plug in a 3, just a normal 3, into y equals x squared, what do I get for y? If I plug in a 3 for x in y equals x squared, I get 9, right? What if I plug in a negative 3? The opposite of what I plugged in over here. What if I plug in a negative 3? What do I get?
9.
I get the same thing. They're equal, right? So if you get the same y value on this side as you do on this side, whether you plug in a 3 or you plug in a negative 3, whether you plug in an x or you plug in a negative x, you're going to get the same y value. If that happens, you have an even function. They're symmetrical to the y-axis. Okay? Odd function, like y equals x cubed. Okay, so this, right? If I plug in a 2 into y equals x cubed, what do you get? What's 2 times 2 times 2? 8. Okay? So if I plug in a 2 into y equals x cubed, I would get 8. Okay? That will equal the opposite of f of, wait a minute, did I write that wrong? Yes, sorry. It's f of negative x.
Was that the first one?
The opposite of f of negative x. Excuse me. No, I wrote that wrong. F of x is equal to the opposite of f of negative x. Okay? So when I plug in a 2 into y equals x cubed, when I plug in a 2 there, I get 8, right? What if I plug in a negative 2? What do I get? Negative 8. But then I do the opposite of that, it would equal what I started with. Okay? My fault on that first one, guys. Okay? Alright, so is this function even, odd, or neither one? You could graph it and look at it. Okay? Or you could check to see what f of negative x equals. To do f of negative x, what does that mean you do? You plug negative x into this function, right? I'm going to plug negative x into this function. So negative x squared minus 9. What's negative x times negative x? Positive x squared, right? So when I plugged in negative x into this function, I end up getting the same thing. So when I plug in negative x into the function, I get the same thing as what I started with. What type of function do I have? Even. So x squared minus 9 is an even function. Because when I plug in negative x, I got the exact same thing. Okay? Is this even, odd, or neither? Well, let's check. Again, I'm going to plug in negative x. Negative x squared minus 3 times negative x plus 7. Negative x times itself. X squared. Negative 3 times negative x plus 3x plus 7. So is that the same thing as what I started with? No, so it's definitely not even. Okay? Is f of negative x the exact opposite of the original function? No. That term was opposite, but are the other terms opposite? No. So it's not odd, so it's neither. It's not even, it's not odd, this would be neither. Okay? So that's kind of how you check even, odd, neither. Those are types of symmetry. Alright? taught everything at once, that's because we're gonna be working tomorrow.
Oh, thanks, Jay.
We have a review packet that you'll be very happy about to get you ready for the big test late next week. The only thing I've taught you so far is the front page here.
There's that much more to it?